here's a quick video on what we did this week in trigonometry. So if you didn't happen to get this down in the lesson, you can do now. So just pause the video and then copy it down. Basically, this is the steps to find the missing length. So we're going to label the triangle, pick a formula, set up the equation, and then solve it. We're going to dive right in with a few examples based all on this page here. Okay, so step one is to label our triangle. So in relation to this angle, this is my opposite side because it's opposite the angle, so I'm going to call it O. In relation to this angle, well, some people might think that is the adjacent because it's right beside it, but we have to be careful. It's actually opposite the right angle, and because it's opposite the right angle, well, it's actually the hypotenuse, so I'm going to label it H. This would be my adjacent, but because I have no information and I don't want any information about this side, I'm not going to label it. I'm not concerned with it. So that's step one done. Okay, so let's just go back, make sure we checked off step one. That is to label our triangle. Next thing we got to do is pick a formula. So which formula involves the opposite and the hypotenuse? Well, looking through these, it's actually this one. This is the formula I'm concerned with because that has opposite and hypotenuse in it. Neither of these two formulas has opposite and hypotenuse, so I'm going to use this sine formula. So I know that sine of the angle, or theta, so sine of 40 is equal to the opposite x over the hypotenuse, 11. So that's step two, pick my formula. Then I'm going to set up, that's the equation set up as well. Next thing we want to do is solve it, and in order to solve it we can use these triangles here. So what I'm going to do is cover what it is I'm looking for. I'm trying to solve for x, so I'm looking for the opposite. So I'm going to cover the opposite. And that tells me, in order to solve for x, what I have to do is times the hypotenuse by the sine of the angle. So I can do sine of theta, sine of 40, and then times it by the hypotenuse, 11. So in other words, I'm going to do sine of 40, I'm just going to put brackets up, and times that by 11. And when we do that on my calculator, we get 7.07. So it's 7.07. This is in centimeters, so my answer is in centimeters. And that's it. Job done. Let's have a look in the middle. Step one is to label my triangle. So let's label it. In relation to this angle, this is the opposite because it's opposite the angle. And in relation to this angle, this is my adjacent because it's beside. Remember, the hypotenuse is always opposite the right angle, so this must be my adjacent. Alright, that's step one. Now I've got to pick a formula. So which formula involves opposite and adjacent? Well, looking through my triangles here, I can see that this is the formula I'm dealing with. It's the opposite and the adjacent. So now I'm going to set up my equation. So I now know that, let me work that out, should be this. I know that tan of 20 is equal to the opposite over the adjacent. Opposite is x, the adjacent is 7. So that's my equation set up. Now I've got to solve it. So in order to solve it, in order to get x, what we do is we can use a triangle to help us. So take your hand, come and cover up what it is we're looking for. So in this case I'm looking for x, or the opposite. So I'm going to cover the opposite. And that tells me in order to get that, I have to do tan of theta times the adjacent. So it's going to be tan of 20, put brackets up again, times the adjacent. Just to let you know, the reason why I'm putting brackets up here is if I put into my calculator tan of 20 times 7, just like that, what your calculator will do is it will do tan, or it will do tan of 140, which is not what we want. So that's why I put the brackets up, just to protect it. Again, let the calculator do all the work here. Tan of 20 times 7 gives me 2.55. So that's our answer, 2.55. Alright, job done. Let's have a look at another one. Right. So, step 1, label my triangle. So in relation to this angle, this is my opposite because it's opposite the angle. This is the adjacent because it's beside the angle. And this one here would be the hypotenuse, but we're not really bothered with that. These are the two pieces of information we're given. So that's step 1. Step 2, choose a formula. Which formula uses opposite and adjacent? Tan. Okay, we've already dealt with this. So I'm going to set up my equation. Tan of the angle 30, tan of 30 is equal to the opposite over the adjacent, so 3 over x. Okay, and then I have to solve it, so I'm solving for x, so I want to know what x equals. Now in order to solve for x, well, again, we cover up what it is we're looking for. In this case I'm looking for the adjacent, so I'm going to take the hand and cover the adjacent. And that tells me what I need to do. I need to do the opposite divided by the tan of the angle. So in other words, I'm doing the opposite, which is 3. I'm dividing that by the tan of the angle, tan of 30 degrees. When we punch that into a calculator, 3 divided by tan of 30, we get 5.196, and when I round that off, I get 5.2. That's rounded to 2 decimal places. Again, that's in centimeters. Alright, one more quick example. So this case, we're going to label the triangles. This is my adjacent because it's beside the angle. This is the hypotenuse because it's opposite the right angle here. Right? Hypotenuse is always opposite the right angle. So that's step 1. Step 2, choose a formula. Which formula uses adjacent and hypotenuse? Well, quickly browsing, this is the one I'm concerned with, that cosine. Cosine uses adjacent and hypotenuse. So I'm going to set up my equation now. So cos of 20 is equal to adjacent over hypotenuse. Adjacent is 9, hypotenuse is x. Now I'm going to solve it, so I want to solve for x. In order to solve for x, let's take the hand and cover up what it is we're looking for. In this case I'm looking for x, so I'm going to cover the hypotenuse, cover that up, make it a bit bigger, cover the hypotenuse. I've got to do the adjacent divided by the cosine of the angle. So I'm going to do the adjacent, which is 9, divided by cos of 20. Now I punch that into my calculator, we get 9 divided by cos 20, 9.58. That's it, 9.58 centimeters. And that is how we use our trig functions to find a missing length when given an angle on one side.